In this course, we'll build a solid foundation in CAD by learning SOLIDWORKS step by step. We'll start with the basic interface, sketching, and a simple extrusion, then build from there. Welcome to the Learn It channel. Let's start learning SOLIDWORKS. Hello, and welcome to this 10-part CAD course focusing on SOLIDWORKS design. The purpose of this course is to give you a well-rounded foundation in the fundamentals of the SOLIDWORKS platform so you can create designs independently. Across these 10 lessons, we will look at a general system overview and proper design fundamentals. We will cover features like extrude, revolve, sketch, fillets, chamfers, the hole wizard, and more advanced features like patterns and mirrors. Then we'll introduce assemblies and bring everything together into a fluid and practical manner. In doing this, we will focus on proper CAD fundamentals that are transferable across many different CAD systems. With that said, let's open the part and see what we will be working on. This is the final product that we'll be designing throughout the 10 lessons. As you can see, it is a cooler with a cup, lid, base, and handle. This project will teach us the fundamentals we need while packaging them in a recognizable and familiar shape. We like doing this way because it helps connect the real world with CAD, makes certain concepts easier to teach, and lets you see your designs come to life step by step. That being said, we'll not design the entire cooler in lesson 1. We will move slowly and carefully so that you understand everything we click and every decision we make throughout the design process. For lesson 1, we will focus just on the lid, but not even the full lid. We will learn sketching, extruding, and other simple fundamentals. Then continue building the lid throughout lesson 2 and 3 until it matches what you see here. Another part of this 10-part course is the homework or review parts that go along with each lesson. These bonus homework drawings are provided for our Patreon members as a way to continue learning and support the channel. For example, throughout lessons 1 to 3, the Patreon homework project is a cutting board. We will learn the tools on the cooler, and then you can challenge yourself with the review part shown here. Patreon members will receive a drawing with the dimensions, and then it's going to be up to you to go through the process and design each step. In lesson 3, we're going to round out the cutting board and give you a final step to do. Then throughout the later lessons, we'll use other parts that make more sense for the skills and features we are learning. But enough introductions and enough explanation of what we will do throughout the course. Let's start lesson 1 already. I'd like to show you a few settings for working with the UI or user interface, and then we will talk through everything you see on the screen. One setting we need to look at is in the window settings, not necessarily inside SOLIDWORKS. This is the text size or font size. To change that, go to Windows Accessibility, where you can change the text size. If the text is very small, this setting is going to help immensely. If you have a high resolution screen like I do, you may need to increase the accessibility text size to make the menu text or FeatureManager design tree text larger. I'll show you that in due time when we get there. Everything else related to size can be adjusted inside SOLIDWORKS itself. When we first open SOLIDWORKS, we will see this welcome or flyout preview screen. I don't personally use most of the items up here, including many of the resources and recent folders. I usually only click a recent document if it's something I've worked on recently. Here we can see the cooler and cutting board in the recent documents list. More than likely, we will work with these buttons here, which are part, assembly, and drawing. Or we will open a part that we need to work on. So one final caveat, this is not a tutorial on installing SOLIDWORKS or on the differences between SOLIDWORKS Design Professional, SOLIDWORKS Maker, SOLIDWORKS Education licenses, and so on. That could be its own video series just covering the license differences. CAD installation could also be a completely separate series because of the complexity. So again, just to make that clear, I'm assuming you already have SOLIDWORKS installed and can get to this point. But if you are struggling at any point, feel free to write that in the comment section below, and we'll try our best to get back to you in due time. In the bottom left, you can see the installed version of SOLIDWORKS. In this case, I'm using SOLIDWORKS Design Professional 2026. SP 2.0 is the service pack I will use throughout this lesson plan. Okay, so let's go ahead and open a part, and then we can get into the user interface. So one thing to make sure we understand fully about CAD and CAD model architecture is that the part holds all of the information. So an assembly is going to be working off of a part. You can't work on an assembly until you have parts to put into an assembly. The same goes for the drawing. You cannot make a drawing until you have a part that can go into that drawing. The easiest way to think about it is that the part is the source of truth, or the source of all the data, while the assembly and drawing are downstream for that, or things that we'll address later on in the design process. Jumping into a part here, we don't have to name anything right away. As you can see at the top in the middle, this area shows our file name. Since I haven't set a file name yet, SOLIDWORKS uses the default name, which is part 1. Now let's go over the interface and what we are looking at when we launch SOLIDWORKS. Let's focus on icon size first, because my icons are probably larger than yours. I have already changed the settings, so I'll have to go back and show you how it looks by default, just to make sure that we're all on the same page starting this. So we'll click OK on that. Now this is what you're going to see on your screen. The default is using small icons. At the top left is your main menu with icons such as Home, New, Open, Settings, Rebuild, and Save. Now under the Options tab or Options button, there's a small arrow. Drop that down and you'll see button size at the bottom, where you can choose small, medium, or large. Now I personally like to work with small icons when I'm doing CAD work on my own, but when teaching or presenting, it's best to use larger icons. So medium is a little bit bigger, but for this video, I will use large so everything I do is easy for you to see. Coming over to the right-hand side, this is the 3D experience page. This is tied into SOLIDWORKS parent company, and here's my best French, everyone, Dassault Systèmes and their document management tools. So for this course, you'll probably not need to use this area for quite a while. Yes, I grew up in Canada, but my French is not the best, so you'll have to forgive me for that. So we can collapse this and not worry about the right side of the page for now. So you may have this panel pinned open. It should work as a flyout. If you click in the gray space behind it, it should pop out. And then we do not need to worry about this panel on the right-hand side any longer. If you click in the gray area and it does not hide, then the panel is pinned. To fix that, go up to this thumbtack icon. Click the thumbtack until the pin is horizontal, then click in the gray area and the panel hides. Now let's come over to the left-hand side. On the left side, I'm going to stretch the interface a bit so you can see everything. You may not need to do that yourself, but to start, we will focus on this first tab, the FeatureManager design tree. The design tree is a history or log of all the features you have in the file or part. Every part already has these folders. You'll see history, sensors, annotations, material, and other items like that. For now, you don't need to touch most of these. The front, top, and right planes along with the origin are very important. This is the 0 point of our file. It's the nominal reference point where we use to build the part. A bad habit some engineers or designers have is not designing from these origin planes. Instead, they design out in space. Now that might work for prototyping or design review, but as soon as you want to use the part in assembly, machine it, or follow proper design for manufacturing practices or DFM, designing out in space can cause a ton of headaches. We always want to reference everything back to the origin. So we'll go over that more later, but for now we don't need to worry too much about it because our focus is understanding the buttons and how the system works. Later we're going to discuss proper DFM design in more detail. So what I'm getting at is this: don't delete any of these planes because they're fundamental and very important for any design. So if you remember, what our goal is for this lesson is we want to design the cooler lid. Now this isn't going to be the full lid yet, but we're starting it. One of the most important habits for any part is saving consistently. To save a part, we first need to create it. We can click the Save button up here to create our file and start working with it. If I open the Save icon dropdown, there are a few options including Save to this PC and Save to 3D Experience. If your interface says Save or Save As, that is effectively the same as saving to this PC. My setup has a connector to the 3D Experience Cloud and PLM system, but we will not need to worry about that right at this moment. That would definitely be for a future course, but for our purposes, we will use Save to this PC, Save or Save As. When I click that, it takes me to the last local location I saved to. So as you can see, I have a folder structure here with files for this particular course. Inside lesson 1, the file you can see is actually the Patreon homework, which is our review part. But now let's add the cooler lid here. We're going to call it the cooler lid. You don't have to type it exactly the way I do. You can use a space or an underscore. I prefer not to use spaces in final file names, which is mainly for programming and compatibility reasons. This is simply how I name files, so feel free to use the same approach if you want to follow good practices. But for hobbyists or small startups, the exact file name is not the biggest issue. The important thing is that the name is understandable. So I will click Save, and we can see that at the top now. There it is, the cooler lid file has been created. It is saved as an SLDPRT file, which is a SOLIDWORKS part. And now we are finally ready to start the design. So when you start a design, there are many different ways to do almost anything in SOLIDWORKS. I'd like to teach you an industry best practice method that supports parametric modeling. In simple terms, parametric modeling makes it easier to edit or alter your file without breaking it. So once you've been designing for a while, you will eventually break a model and need to repair references or other relationships in the file. But parametric modeling helps prevent most of that. Some CAD companies or resellers will say you can skip many of the steps that I want to show you. They might say that it's faster to use blocks or shortcuts. While that can be true, from my experience and from an industry perspective, skipping these fundamentals can set you up for huge problems later in your CAD journey. That being said, if you're going to ask 10 people, you might get 10 completely different workflows. But we will follow industry best practice. We're going to create a sketch, extrude or revolve it, and then add finishing features like fillets or chamfers. Okay, so let's add our first sketch. As a quick reminder, we are designing the cooler lid. You don't need the final file itself right now. We will go step by step. I just wanted to remind you what we're designing. I will jump back into the file and now we're ready to start sketching. So up in the Sketch tab of the ribbon, we want to click Sketch. Now we need to select a plane. This is where design practices come into play. For a typical extrusion, I like to work top down. I usually sketch on the top plane and then extrude normal to that plane. We can simply click the top plane no matter how the model is currently oriented. However, I like to lock in the view orientation first, and the sooner that you make that a habit, the better. So what I want to do is have a top-down view. I can orbit the view the way I'm doing right now by holding the middle mouse button and then dragging the mouse. So give that a try yourself. So that's how you orbit. Right-click gives you a context menu with relevant options, and left-click is your selection click. So in this case, I want to orient myself to the top plane. If I click this orientation menu, it gives me an interactive box I can work with. Now these are different views you can select. If I hover over one, SOLIDWORKS gives me a preview. Since I don't have any geometry to show yet, the preview doesn't really help us at this point in time. But I found that this interactive box can be a little overwhelming for beginners. It can be helpful in certain areas, but while you're learning, I recommend working with these view icons instead. These are the classic 6 views. So we have top, bottom, left, right, front, and back. For now, we'll not need to worry about the interactive display. So for now, let's not worry about that interactive display. We will use this view orientation dropdown, click top, and get a clean orientation of the top plane. So one thing to point out is how the left panel now changes. So if I exit the sketch quickly, I can add another sketch, but let's say I was sketching and accidentally hit the escape key. This is a good point also to bring up my escape key visual aid. If I press escape, you can see what happens. Pressing escape by mistake clears my menu. You might have been trying to click the top plane, accidentally pressed escape, and then lost the command. As you get oriented to the top plane, you can see I am in the sketch menu, and you can see how the flyout window on the left changes. Then we click the plane we want. The message here is helpful because it tells you what the feature needs from you. So this may not matter much for straightforward features, but when we get into much more complex features such as mirror, these instructions will be incredibly helpful to you. Now, I will need to catch back up here for a moment. I will click plane, then top plane, and now I am sketching. I have added and removed a few sketches while explaining this, so mine now says sketch 4, yours probably will just say sketch 1. That's not a big deal, we can just rename it later. Okay, just before we get to the next step, I'd like to send out a huge shout out to our sponsor PCBWay. They've got incredible services. I'd just like to highlight one of them today. Let's go on over to PCB Design. Here you can see you can create professional electronic designs for your next project. This is amazing. You can upload your design here. You can get quotes. You can get help from professional engineering teams, end-to-end development, fast turnaround, manufacturing advantage. And note some of the turnkey electronic design services. You have PCB layout, PCB design, and mechanical and enclosure design. Some pretty amazing things over at PCBWay. Please check them out. I've been working with them for 1.5 years now, and I've really enjoyed it so far. Thank you, PCBWay, for your support. Hope you guys check them out. So now we're ready to do some sketching. So if we look at the sketch ribbon, there are many different tools, but right now let's just focus on the line tool and the corner rectangle tool. We'll not need to worry about the other sketch tools right now. They all definitely serve different purposes, but we can do most of our work with the line command itself. Typically, if I were doing this on my own, I would quickly draw a rectangle and put some dimensions on it, and then define the dimensions. But I don't want to do that here because I want to show you a few SOLIDWORKS concepts along the way. So I will use the line command and explain a few things as we go. So our goal here now is that we want to make a rectangle with 90-degree corners. So SOLIDWORKS tries to be very helpful with doing just that. Sometimes you may not want it to do this, but if I single click, you can see my line is looking for the endpoint. If I get close to vertical, it snaps into place and shows that this is indeed a vertical line. If I left click again, that accepts the vertical line, and I can keep drawing another line continuously. When I get close to horizontal or close to the x-axis, I can click that too. It snaps into place. I can keep going and finish this whole rectangle. I will press escape for a moment so I can explain what is happening. What we did was add constraints to the sketch automatically as we drew. This symbol here is called a vertical constraint. And this symbol here is called a horizontal constraint. So a good practice is to fully constrain your sketch. Down here, you will see underdefined or fully defined, which tells you whether your sketch is fully defined or not. So for parametric design, it's absolutely vital to fully constrain our sketch. So for now, we're not going to worry about that yet, but that is a fundamental skill to keep in mind. But right now, the purpose is just to learn the functionality of the system and the different features. So we will build into fully defining sketches as we go. We will create more sketches and fully define them as we progress. For now, we will make a simple sketch and a simple extrude so we can actually create something. So if I want to continue with my box, I want to close off this box, which another way of saying it is to create a closed profile. So as I hover near the endpoints, SOLIDWORKS gives me a reference point or line. It's asking whether I want a point along a vertical axis lined up with this point. Yes, I do, but I'll show you that on the top. What I'll do is let's click this endpoint on the bottom right, and now I want to close it off with the top endpoint. As I move upward, it snaps vertically and continues until it lines up with the top reference point. So sometimes it won't automatically snap to that reference point. So if I wanted to snap to the midpoint, I may need to hover over the point I want to reference. You can see the midpoint is actually showing up here on the screen. If I expose that midpoint by hovering over it and then moving the mouse cursor away, SOLIDWORKS remembers the reference as if it understands that I want to actually reference the midpoint of that line. So I haven't clicked anything yet. I'm just hovering the mouse cursor. Then I can continue until it snaps vertically. In this case, let's go to the top and use the same methodology. So I'm going to go up to the top. Let's hover over to the right until it snaps vertically and then click with our mouse. So I'm still working in a continuous line, but right now I'm just going to close off this box, which should create a horizontal line and then complete the shape, turn it into what's called a closed profile. So we can see that the square is now filled in. When that shape fills in, again, just as a reminder, it's called a closed profile or an enclosed region that can be extruded or revolved to create a 3D body. Let me draw another quick example. If I leave a small gap, this isn't shaded because the sketch isn't fully closed. If I click and drag this to close it, you can see it shades itself, showing that the sketch is fully enclosed or fully defined. So now we have a square, or something close to a square, we could say, but we don't know the size of it yet. And it can still move around freely if we click it with our mouse and then move. So this is something that we need to emphasize again and again. This is not good for best practice, but it's okay for now because we're learning the tools and getting familiar with SOLIDWORKS. So ideally, we don't want to move this around. We would want it to be constrained fully. For now, though, we'll just focus on getting familiar with SOLIDWORKS. Now, let's add the dimensions to it. I want the bottom line and the top line to be 400 millimeters or 40 centimeters long, and the other sides, the left and the right sides, to be 250 millimeters or 25 centimeters tall. So for the next step here, I'd like to use what's called Smart Dimension. If you open this drop-down menu, there are different types of dimensions. You could use these, but most CAD systems now have a single Smart Dimension option. So if you click on a round part, it assumes you want a radius. If you click on a line, it assumes that you want a distance. It saves you a step because you don't have to choose the exact dimension type before clicking the sketch geometry itself. It's kind of like the Swiss Army knife of dimensioning. So here, let's add a dimension to this top horizontal line. When I click the horizontal line, SOLIDWORKS recognizes that I want a full length dimension from left to right, which is perfect in this instance. I will left click in open space where I want to place the dimension. And right away, we can see that this is an inch dimension. Remember, we're talking here about 400 millimeters or 40 centimeters. That is metric, but we're currently working in an inch file or using inches in our document settings. Don't worry about this. We're going to switch this in just a moment, but I can use this as an opportunity to show you how to use multiple units inside the same file. The default here is that when I start typing 400, SOLIDWORKS wants me to specify a unit. If I press enter without entering a unit, it will use the default file unit. So in this case, the default unit is inches. I can either pick millimeters here or simply type mm after the dimension. This means that no matter what the filed unit is, this dimension will be exactly 400 millimeters. When I press enter, the dimension is accepted. Let's use this moment now to show how we can reorient ourselves in this view. Now, people don't always talk about this because it's like second nature, but let's just go into a little bit of detail here. If we hold the left control key and the middle mouse button, I can pan or go left to right, up and down. So that is helpful when I'd like to look around a sketch. But in a sketch, you generally don't want to orbit the view like I'm doing on the screen right now. So when we orbit into a third dimension, it's just more likely to create errors or to be confused. So let me reorient things again. Let's get ourselves back to this top view. And here again, we can just hold Control and the middle mouse button to pan, or we can zoom in and out using the scroll wheel on our mouse. So you'll see me zoom in and out a lot myself just to orient things. So zooming in and out again is just based off of the mouse cursor. So give it a try with your model, zoom in and out. And when I zoom out, the view behaves more like it's referencing the overall origin. So when I zoom in, it's based more on where my mouse cursor is. So if my mouse is over here, you can see that I zoom in toward where the mouse cursor is. I use my mouse like a pointer to zoom into the area that I want. So I'd like to reset my view again. I can move quickly by zooming out first. Then it doesn't really matter exactly where I am. Then I place my mouse cursor near the area I want to zoom into, which is the middle of this rectangle. I keep moving my mouse constantly as I zoom so I can zoom in or zero into the area that I want. So I adjust as I go just to hone into that specific area of the part. So now back to the dimension. We have specified here 15.75 inches. If I double click that dimension, it looks like a strange dimension. It does not say 400 millimeters, but it is equivalent to 400 millimeters. So what I want to do now is edit the files unit system to be metric instead. So down in the bottom right, you can see IPS, which means inch, pound, second. So this is effectively an inch file. So let me hide my escape key visual here so that I can show the units more clearly. We have different options here. Typically, I usually choose between millimeters and inches. For this case, we've been talking about millimeters, so let's go ahead and work in millimeters. I will click MMGS, and you can see it right there, MMGS. So that effectively changed the file to a metric file. It also finished my sketch for me. So the sketch now appears in this light gray color. That means that SOLIDWORKS itself automatically exited the sketch. So I'm not in this sketcher anymore. I need to go back and edit the sketch to finish this. So now let's go over to the FeatureManager design tree on the left side, right-click the sketch, and use this icon called Edit Sketch. There we go. The difference now is that we no longer see 15.75 inches. We see a clean 400. So now let's finish the sketch. Let's click on Smart Dimension and then click on that vertical line on the left. Now you can see it defaults to millimeters, which is fantastic. We will simply type 250 to specify 250 millimeters. I don't even need to type millimeters because it's defaulting to the metric system. So I can just press enter and then zoom out and see where I want to look at. Now that's looking great. I will turn the escape key visual aid back on so we can see it. I'm still in the Smart Dimension command because SOLIDWORKS keeps the command active so that you don't have to keep clicking the menu every time you want to use the previous command. So commands and features usually stay active until you are done with them. You can finish by clicking the green check mark or by pressing escape. So one thing we always want to remember is to keep using the escape key. So like I've mentioned in Autodesk Fusion courses that we've produced, the escape key is your best friend. You may not realize that you are still inside a command or a command is selected in the background. So if you try and use other features while an old command is still active, you can actually make mistakes or affect your file unexpectedly. So for sketching, the easiest way to tell that you're in a sketch is by looking near the file name. So here it says sketch 4, yours might say sketch 1 or sketch 2. The number doesn't necessarily matter in this instance, it just corresponds to the feature that we're currently editing. So okay, we're done. Let's exit the sketch. We have here a clean 400mm by 250mm rectangle, and now we are ready to extrude. So let's head on over to our toolbar and click Extrude. When we do so, the left side tells us what SOLIDWORKS needs from us. We can do one of two things. We can select a plane to start a brand new sketch, or use an existing sketch and bring it into the extrude feature. So I recommend the second option for beginners. Sketch first, then extrude afterward. You can sketch and extrude all in one step if you want, but I would consider that a more advanced technique because you need to know exactly what you're doing and plan a few steps ahead. So let's use that option too. We don't need to do anything different. We are simply choosing the sketch that we just created. So in the extrude command, I will click one of the lines of the sketch that we just made, and now we're ready to start extruding. So you could grab the arrow and move it up or down. I usually only do this if I'm designing a prototype and don't yet know the exact height. For example, I might have a sensor off to the right and use the arrow as a preview to see how much height I need to clear that sensor. So I'd want to make sure that the height is past the sensor, so I use the arrow to drag up and down to a good area. Then I will usually enter a nominal number afterward. But let's just say randomly that this sensor is 150mm tall. I could eyeball it and say it clears, but I still want to make sure that this is a clean nominal number. So let's head on over to the side there and click 160. For the options inside of Extrude, let's not worry about direction 2 at this moment. We'll also not need to worry about thin feature extrude either. All we'll do is look at direction 1. Now that we're inside direction 1, click on the different parameters and options. You might not often use these. They are very situational and often one-off solutions. I almost always use blind or through when we get to cut commands. Blind lets you control exactly how tall the extrude is. Other options such as up to vertex, up to surface, or offset require a reference to another existing feature like another extrude. I usually avoid that because I like to keep full control of everything, even if features share the same surface. So we're going to cover that in a more advanced class about design parameters and good practices in the future. But for now, let's just leave it set to blind. This simply means I want to extrude from the sketch profile to a specific distance that I input again here on the left. So like before, I entered 160. This blue box would be used if I wanted to change the extrude direction. And there are many ways to extrude. So you don't have to just extrude normal to the plane. Right now it's pulling 90 degrees in both directions perpendicular to the sketch plane, or we actually say normal to the sketch plane. And that creates a perfectly straight block. But I could also extrude at an angle such as 45 degrees to create something like a trapezoid. Now to do that, I would create a line and reference it here. But for now, we're just talking about the basics here. So blind and the distance value, and then let's go ahead and hit the check mark. Now I got ahead of myself here and made it 160mm, but it's actually supposed to be 75mm. So I will show you how to measure something in the future, but for now I'm showing you this because I made a mistake and we need to fix it. We can see here that the distance is 160, but it needs to be 75mm. So first tap escape because we want to make sure that we don't have another command in the background. We will right click the boss extrude, just like we did with the sketch earlier, and choose edit feature. Now we're back inside the extrude feature and we will make this 75mm. Press enter, click the green check mark. Now we are back to a proper lid that is 75mm tall, and we're ready for the next step. So that covers what we wanted to show you in lesson 1. One of the most important steps is to save your work. So if you see an asterisk next to the file name at the top, that means the file has not yet been saved. So if it hasn't been saved in a while, SOLIDWORKS will show you a warning window. That is good, and I would not turn that feature off because you always want to keep saving. CAD files don't save automatically like Word or Excel files do. So you need to make sure to save constantly, save often. Simply just click save. The asterisk goes away here, which means that we've saved the work. And now at this point, let's just go and talk about the homework, the Patreon homework or review part for lesson 1, which we currently have on the screen right here. This is a bonus practice drawing for our Patreon members, so I don't want to show you too much here. The point is for you to challenge yourself. The goal is to reach this part without me showing every step to you. So Patreon members will receive the PDF drawing showing the dimensions of the cutting board. A couple differences between this cutting board and what we did in lesson 1 are that the sketch is a little more complex. It's not just a rectangle. We have this offshoot. We have all the dimensions on the screen. They're in inches, not in metric. So everything you see here, such as 15 inches, 3/8 of an inch, 0.375, means you will work in an inch file instead of metric file this time. We are changing the unit of measure and changing the sketch a little bit, hopefully again to challenge you a little bit, but we're confident that you can still create this part. I also removed the wood appearance and returned to the basic shape. Bonus points if you go ahead and try and find out how to apply the wood appearance yourself. But this is the expected output from lesson 1. We will build off of this in lesson 2 and 3 to get to the final product. But that's it for lesson 1. So if you found this beneficial, please consider liking, please consider subscribing and hitting that notification bell for all future tutorials. So thank you so much for tuning in to learn SOLIDWORKS with the Learn It channel. See you at the next one.